It's a pleasure to be here. I'd like again to thank the organizers for inviting me to give this presentation. I realize that many of you probably are not too familiar with parallel discrete event simulation, so I tried to orient the presentation so that you didn't have to have much prior knowledge of the area, but at the same time, hopefully there'll be some things in addition that may be of interest for those of you that are familiar with some of the problems in this field. What I plan to do is actually I wanted to give you an overview of the work that's been going on in parallel discrete event simulation really over the last 30 years or so. It's been going for some time, and just give you a sense for what, how this thing got started and what the current state of the art is, and then at the end what I want to do is to talk about some of the challenges in exploiting technology. So the overview for my presentation, you can see it's very much historically oriented. I'll start with talking about the early years and some of the seminal work in the field. Then I'll talk about the work going through the 1980s, 1990s as the field matured, and try to give you a sense for where the technology is today. And then at the end, what I wanted to do was to speak a little bit more broadly and hopefully begin some discussion about the question of should modeling and simulation as a field develop some common research agenda that we all agree are some of the important problems of this discipline that really need to be addressed. So that's the plan. That's the plan for the presentation today. Before I get started, just to set some context in terms of what do I mean by parallel discrete event simulation, what exactly am I talking about? My concern is, of course, discrete event simulation applications. I'm sure you're all familiar with discrete event simulation. These just illustrate some of the typical application areas where discrete event simulation is often applied. And as you can see, it's certainly a very important area that covers many of the most challenging problems that are with us today, and simulation clearly plays an important role. Now, my interest is discrete event simulations, but what I want to do is I want to exploit parallel processing to speed up the execution of simulations. Now, there are several different ways of exploiting parallel and distributed computing that I want to articulate, and for this talk, I'm just going to be focusing on one particular approach, which is what I've depicted here. The idea is to take a single discrete event simulation run and distribute its execution over multiple processors in order to get the whole thing to run faster. So I'm just taking a single run, trying to get a single run to execute in much less time than would otherwise be required. And of course, the way one goes about doing this is if you're simulating some type of networks I've shown here, then the idea is you chop it up into subnetworks, map each of the subnetworks to different processors,